For the problem statement, so Malaysia has a target of 70% renewable energy by the year of 2050 and largely is contributed by solar. And increasing of rooftop solar as causes voltage regulation and reverse power flow. And current grid planning approaches are not fully integrated with real-time solar, load and weather data for dynamic decision making. And also current hosting capacity assessment are static and not predicting future conditions. And solar PV capacity is projected to increase from 7 gigawatt in 2030 to 57 gigawatt by 2050, which will significantly increase the stress on distribution networks through voltage regulation issues and bidirectional power flow. Besides, there is also a do you know reality. So, Malaysia is already experiencing midday solar oversupply, and beyond 40% of penetration, solar output must be curtailed to maintain grid stability.
So what is our solution? Our solution is a web-based dashboard that monitors feeder conditions and predicts solar-related grid risk in real time. It helps operators manage access rooftop solar mode effectively and support safer DER integrations. The input parameters are obtained from TNB, such as feeder voltage and other monitoring data from SCADA.
So the dashboard is designed to gather important information from TNB monitoring systems such as SCADA, smart meters, feeder monitoring systems, and substation monitoring platforms. It shows the key feeder data including feeder voltage, feeder current, solar generation, load demand, net power flow, and hosting capacity, so operators can view everything in one place more easily. On the right side, the dashboard provides risk predictions such as voltage rise risk, reverse power flow risk, and hosting capacity status. Together with the recommended action, in the lower section, the control scenario allows us to adjust parameters and observe how the prediction changes. For example, increasing the sensitivity makes the feeder more prone to risk. Reducing feeder capacity limit the hosting capacity, and when I increase the power, export power, it will raise the reverse power flow risk. The dashboard also includes graphs such as voltage over time, solar versus load, and net import versus export to help visualize feeder behavior. For example, when the solar generation increases, the peak voltage appears around 1 p.m., which is consistent with the normal solar peak in the afternoon. Lastly, the system keeps a log of previous daily risk events, which helps improve monitoring reliability and supports better prediction over time.
So these are the formula being used to obtain the code to generate the predictions.
Next, this is our flowchart or our system architecture for this project. So, firstly, there will be a need to have input parameters from TNB, and the input parameters will be fed to user interface, data processing module, and the predictive or inference engine. And then once the data being processed, the data will be sent into the risk prediction and recommended action, and also will be sent to the AI or rule-based decision model. And this AI, we have already trained it with sample data from Kaggle to get more accurate results. And then finally, we will show all of the result on a dashboard visualization for ease of understanding of the current data.
So in terms of feasibility, SolarFlex integrates existing TNB systems such as AMI smart meters, SCADA, hosting capacity tools, and weather data into a single AI platform. It processes real-time data to assess feeder conditions, predicts risks like reverse power flow, and recommend actions to operators. Since it builds on existing infrastructure, it requires minimal additional hardware, making it a practical and highly feasible solution for deployment in Malaysia. Moving on to economic viability. So first, SolarFlex improved the cost efficiency. It making better use of existing infrastructure like AMI and SCADA. Next, it reduced curtailment losses. For example, just 1 megawatt of curtailed solar can lead to over 200,000 loss per year. So, reducing this brings significant savings. Finally, SolarFlex increased revenue opportunity. Faster solar approvals leads to more installations, more grid usage, and support the growth of the solar industry. So overall, SolarFlex reduce cost by minimizing losses, improving efficiency, and making grid investment smarter. Now, for sustainability and impact. So, Solar Flex enables higher solar integration while reducing curtailment, ensuring clean energy is not wasted. It improves grid resilience and energy security by managing voltage and reverse power flow in real time. Economically, it reduces losses, speeds up solar adoption, and minimizes unnecessary grid upgrades. Overall, SolarFlex supports Malaysia's transitions to a reliable, efficient, and sustainable energy system.